All right. Yes, looks perfectly fine. So now, welcome to everyone to today's NFDI talk. This episode is an introduction to PID4NFDI service components. PID4NFDI operates as a basic service within Base4NFDI, supporting persistent identifier adoption across the NFDI ecosystem by building on established PID infrastructure providers. This talk today gives a structured overview of the current service portfolio, covering components that range from training and documentation to technical service integration, and situates them within the adoption challenges that NFDI consortia have identified. It closes with an outlook on the planned ramp-up phase and what consortia can expect from PID4NFDI going forward. And as our speakers today, we welcome Jana Böhm, Sara El-Gebali, and Torsten Kahlert, who I will quickly introduce to you now. First off, Torsten Kahlert is a research data specialist at TIB Hannover and responsible in PID4NFDI for training material development, documentation, and community outreach. Sara El-Gebali is a metadata specialist at DataCite and part of the PID4NFDI project team, where she leads the metadata analysis and harmonization efforts around FAIR principles and PID infrastructure. And our third speaker, Jana Böhm, is a research data specialist at GWDG Göttingen and contributes to PID4NFDI with a focus on PID service integration, technical architecture, and infrastructure development. And with that short introduction, I'm happy to hand over to our speakers. Yeah.
Thank you very much for the kind introduction. Let us dive straight into who we are and what we offer the NFDI community with our basic service PID4NFDI. But first, to give some context, what exactly is a basic service? Base4NFDI was established as a joint initiative by all NFDI consortia to address shared needs across every discipline. The idea behind basic services is straightforward. Instead of each consortium building the same solutions independently, Base4NFDI develops them jointly and makes them available to all. These are not purely technical infrastructure services. Some provide tools and platforms, others focus on making existing resources accessible and usable. And some, like PID4NFDI, put consultation support at the heart of what they do. That is why training, guidance, and curated information are central components of every basic service, including ours. PID4NFDI is our answer to one of the most fundamental shared needs across all of NFDI, persistent identifiers. PID4NFDI brings together 4 partners with complementary expertise. The TIB hosts, for example, the largest UI consortium worldwide and leads the project together with GWDG. GWDG Göttingen and DataCite are both PID providers themselves and infrastructure partners with deep technical expertise. And Helmholtz brings a strong network for outreach and community engagement across the research landscape. Together, our goal is to harmonize the PID service landscape within NFDI, technically, organizationally, and methodologically. And importantly, we are not building yet another PID provider. We integrate and coordinate what already exists. So what are we trying to solve? 5 challenges stand out here. First, it's fragmentation. PID solutions have grown organically across disciplines, use cases, and life cycle stages without more or less coordination. So there's no shared map, and that is exactly what we are working to change. Secondly, interoperability. PIDs and PID systems need to work across disciplinary and institutional boundaries, and that requires the use of internationally established standards and protocols. Third is support. PIDs and their metadata are only as powerful as people's ability to use them well. Training and guidance are essential to operationalize FAIR in practice. Fourth is governance. Persistent identifiers require persistent commitment. PID policies and guidelines are needed to ensure that identifiers remain stable and can be used across services. And fifth, networking. The PID landscape is international, but connecting NFDI with national and international PID stakeholders remains a gap we're actively working to close. So let me say this out loud because it's worth repeating. The PID doesn't make research fair, the metadata does. PIDs identify and connect. They are persistent, globally unique, resolvable identifiers that link research outputs across systems, publications, data sets, instruments, people, organizations. But a PID alone is just, let's say, a label. Metadata makes PIDs actionable. Structured metadata is what makes an output findable, accessible, interoperable, and reusable. A PID without rich metadata is essentially less or not visible. And then there is connection metadata, because PIDs don't just identify, they relate. As you can see on the slide, a paper cites a data set, a researcher is affiliated with an institution funds an output. These relationships expressed as structured metadata are what turn isolated identifiers into navigable research knowledge graphs. The PID4NFDI coordination hub is, for us, the coordinating layer that brings together information, infrastructure, and community, a single entry point for all PID-related questions within NFDI and beyond. So in the next section, we will walk you through our concrete services, from training resources, decision support tools, to PID registration and technical infrastructure, to semantic interoperability. So let's start with our service portfolio components and with consultation and support. Consultations are our most direct point of contact with the consortia and their communities. And so far, also our most important way of doing what we're here for, helping with the integration of PIDs and improving metadata quality in practice. In the integration phase alone, we have conducted more than 50 consultations, ranging from short-term advice to in-depth collaborations. A selection of these is documented as use cases on our website. Whether you have a concrete question about PID selection or metadata quality, want to suggest a topic, for example, for training resources, or are interested in a deeper collaboration, we want to hear from you. If our proposal for the ramp-up phase is accepted, we will formalize this consultation framework further, developing into that it describes differentiated formats in terms of scope, effort, and expected outcomes. So the second component is our cookbook. This is a practical guide for anyone getting started with PIDs. It provides step-by-step guidance for understanding and implementing PIDs in real workflows, not as a replacement for the documentation of individual PID services, but as a navigational layer that helps you find the right information at the right time. So it covers the most widely used PID systems within NFDI, and it's still growing. So we're open also for extensions and community contributions. The second one is a curated collection of existing PID training material. We created a collection of more than 50 training resources with a clear focus. So the materials in the collection must have a primarily address focus on PIDs. So it's not general research data management material. The collection draws from a wide range of sources, PID providers, EU projects, research infrastructures, and more. And it's structured into 6 sections, starting with the general introduction to the PID ecosystem, then moving into specific systems like DUI, ORCID, ROR, Epic Handles, and ARC, and also covering instrument PIDs, software identifiers, and broader collections and portals. You can filter the collection by resource type, provider, domain, language, or proficiency level, so you can quickly narrow down what fits your needs. The collection also features our own outputs from PID4NFDI, including the just mentioned cookbook and also our Zotero library that is a publicly accessible reference collection of literature related to PIDs and fair research data management. And then we have here an example for training material that was developed by us or is developed by us. So this course is in its final development stage. It's a self-paced online course on registering IGSN IDs built with LIA script, and it will be published under an open license. It is aimed at infrastructure managers and data stewards in NFDI consortia who are implementing IGSN ID workflows or are interested in doing so in the future. The course covers the essentials, for example, what IGSN IDs are and how they relate to DOIs, which objects are eligible, how to register them, and when to involve a registered service provider. The course takes about 15 to 20 minutes, includes interactive knowledge checks and a final assessment. This course is kind of a first module in a planned modular structure. We are piloting the format here before expanding it to other PID systems. And with this, I hand over to Jana, who will go on with the PID selection tool.
Yeah, thank you, Torsten. So as you might know, there are many different PID systems and providers out there. And it can actually be challenging to choose a suitable PID service when implementing a PID use case. And yeah, when choosing a PID, it's actually recommended to look at various different aspects. So the first one is governance and persistence. So PIDs cost money, and different providers have different cost models that might be worth to compare when choosing a PID for your use case. When you look at metadata and interoperability, one could ask the question, do I prefer a PID service with a fixed standardized schema, or do I maybe prefer to use a customized or define a customized schema? There are technical features that one should take into account, for example, whether one wants to self-host PID infrastructure or one requires a PID provider to do this. And this PID selection tool will assist in decision-making by walking a user through 12 statements covering such aspects. And the user will then respond to those statements, and the tool will then compute an overall fit with different PID services. So currently there are 4 PID services supported by the tool, that is DataCite DOI, Epic Handles, URN, NBN, and ARCs. Next slide, please. So after a user would have responded to these 12 statements in the tool, he would then get a summary with a score for each of the 4 PID services that describes how good it fits to the use case requirements. And also he would get textual descriptions that explain the fits in more detail. And the overall value of the tool is, first of all, reflection support. So it is actually not super easy as a user to understand the requirements of the use case and ask the right questions to choose a suitable PID for the use case. And background knowledge and learning effect. So each statement in the tool also has more information that contextualizes the PID services and how they relate to the statements in the tool. And hence it serves as a mini knowledge base, so to say. Next slide, please. So the next one is the PID, the prefix registration service. So now we are moving from the information services before to concrete PID registration. And our aim is also to encourage NFDI consortia to easily get started with PID implementation. And for this, we offer the prefix registration service, where you can receive a PID prefix for your PID use case. And this would allow you to register and manage PIDs under this prefix. So the PIDs that you can receive here are handles, which are issued by GWDG as a member of the Epic PID provider. And these PIDs or prefixes are for free up to 50,000 PIDs per year and during the PID4NFDI project runtime. But if longer term use or higher volumes of PIDs would be required, this is out of scope of this prefix registration service. Next slide, please. The next one is the PID-inst federated search. Now we are coming to added value services that are not about PID registration itself, but about working with existing PIDs and existing PID metadata. And starting with a bit of context, increasingly often PIDs are assigned to instruments, where instruments are devices used for making measurements. Yeah, that could be microscopes, cameras, sensors, and so on. And instrument PIDs then identify the devices themselves, so the real-world assets or instances with capabilities and configurations, rather than model numbers or so. And the aim of instrument PIDs is to improve the interlinking of generated research outputs and enhance the fairness of generated research outputs. As an example, when we link a data set to the instrument that generated it, that would provide more detailed provenance information for the data set, for example, detailed technical capabilities. And of course, we are not the first ones talking about instrument PIDs. So there's the PID-inst working group from the Research Data Alliance, which has already generated quite some outputs towards PIDs for instruments. And one of them is the PID-inst metadata schema. Next slide, please. So the PID-inst metadata schema is a schema that is commonly used for registering PIDs for instruments, and it has 13 properties. And this schema is implemented by two services. So the B2Inst service that is offered by EUDAT and the DataCite service. And what PID4NFDI did is to build a federated tool that combines both these services into a federated search service. And here I also want to mention on the bottom right of the slide, we also have instrument knowledge base on PIDs with use cases, and with guidelines or guiding material about how to register the PID metadata, so how to do it best, and how to interlink instruments with other research outputs. Next slide, please. So going back to the PID-inst federated search, this search combines all instruments registered with either B2Inst or DataCite into a federated search tool. So the first capability is searching of this tool. And then you can use it to find instrument PIDs, to find connections to other resources, for example, data sets. So here the image on the right shows some connection graphs. And you can also use the tool to explore the metadata and the statistics in the statistics section of the tool to produce some nice graphics as at the left image. Next slide, please. The next component I want to show is the PID meta resolver. As I have already mentioned, there are many different PID systems, and these different PID systems rely on different technical foundations. For example, each PID system has their own resolvers. And the idea of the PID meta resolver is to provide a unified interface for PID resolution. So the resolver, just to repeat, the resolver is the tool or the service where you put this PID string in, and this would then resolve to the resource, to the metadata, or to a landing page. And this tool can be used then to resolve PIDs independent of the PID system and without knowing which resolver to use. And one can also choose whether one wants to resolve to the landing page, to the resource itself, so the data set also, or whether one wants to directly go to the metadata. And this tool was first developed in the FAIRcore for iOS project and is now being offered to NFDI through PID4NFDI. And currently there are 49 different providers supported in this tool, and more are likely going to follow. Next slide, please. And last but not least from my side is the data type registry. Here I want to first start with motivating why is a data type registry actually interesting. So some PID providers mandate a fixed and standardized metadata schema, for example, DataCite, while other PID providers allow for flexible user-customized metadata, for example, Epic or Arc. And in the case of flexible PID metadata, we do not want to have a complete chaos or so. And that's why each PID should ideally say which metadata schema it follows when instantiating these metadata. And when a PID says, I follow metadata schema X, then this ensures machine readability of the PID metadata and allows for validation of the metadata against the schema when creating or updating PIDs. And when defining such a metadata schema, it is recommended to register this metadata schema in a data type registry so that it is accessible for other people. And this would also allow to finding and reusing existing schemas or metadata properties, which aims at standardization across systems. And to define a metadata schema for your PIDs, you can reuse existing schemas or properties that are already in the DTR, or you could define new schemas or properties. Next slide, please. So more details about the service. The service aims at infrastructure managers working with flexible PID metadata. And the DTR is a registry for PID information types. So this means you can either register simple metadata properties. For example, you can say an author has a first name and a last name, and each of those is a string. And then you can also define additional properties, and then you can stack those properties together to create the metadata schema. And each of those PID information types, so those properties or schemas, are then assigned a PID for unique identification. And by the tool, these PID information types are also translated into JSON schemas, which then can be used for metadata validation. And similar to the tool before, this was developed in the Faircore for EOS project. And now I'm handing over to Sarah, who will give you some more introductions into our metadata services.
Thank you so much. Thanks, Jana. Yeah, so far we've had a look at how to get PIDs in place, right? And also how to get the metadata in place and how to register the metadata schemas and work with that. So why metadata? Again, why PID metadata? Because PID metadata allows, as we've seen, connectivity, but also what I want to explore here with you today is how it allows interoperability. Because if you think about it, the PID metadata, it rarely really sits in one place. It moves throughout the research life cycle, and then ends up being harvested downstream, or it could be like end up in repositories or portals or knowledge graphs, or reused in entirely different systems at the end. So here's the problem that we keep running into when we want to apply interoperability. So we have a simple scientific statement. We want to say that the data set is derived from this sample. And in the example before you here, we have 4 different either consortia or tools, services, 4 different tools basically, and which means there are 4 perfectly reasonable and there's comprehensible ways of describing that same relationship, whether we're saying is derived from in a structured way or in DataCite, or we're using is based on or was derived from, or even annotating it in free text saying this is derived from that. But every single one of them, it means roughly the same thing. And for us, for humans, we get it. We understand that this data set coming from that sample, whether we see any of these terms. But when that data set moves from one system to another, that meaning gets lost because these systems do not automatically understand each other. They're not like humans. We're talking about machines. They're not automatically understanding that is derived from is the same thing in the free text. So the one from DataCite is the same from free text. And again, I'm not trying to shame anybody and say this tool made a bad choice. No, each tool made an informed choice and based on the real purpose that they needed for. So each vocabulary was designed for a purpose. And the problem here is that we don't have a connective tissue between them. So what happens is that metadata breaks at the boundary. The provenance disappears. And the person who suffers the most is the researcher, for instance, or someone who has to deal with this 3 years down the line, trying to figure out where that data set actually came from. And this is what we call the interoperability problem. So, and that's exactly what we're trying to address in the next set of services that I'm going to go through. So what we have is developed 3 complementary service components. They work at different points in the research lifecycle, and they are designed to work together. Next. Yeah, there we go. Each of these components, I want to say, and I want to make this very clear, it can be used independently in different combinations, or we can help you adapt this to your own context, because each one of them solves a very specific problem. And you don't need to adopt the whole stack. That depends on what you're doing. But when they do work together, as I want to show you in the next few slides, is that what we get is an unbroken metadata flow across different systems. And this end-to-end example I'll show you in a minute is an illustration of what these components, service components, can do together. It's not the only one. It's the one that we have in the pipeline that we're implementing right now. So think about it in a way that if your situation looks any different, that's absolutely fine. We can help you figure out which of these components are relevant and how to adapt them. So let's go through each one of them. We have the first one, which is the semantic integration consultancy. And this component is about interoperability upstream. So that's where we captured structured metadata or structured semantics at the very moment that it happens or when the research happens. So this is like a way, if you're familiar with the research data lifecycle, this is we're addressing interoperability by capturing that structured metadata very, very early on, before the metadata has a chance to drift or change meanings or break down completely or get lost. So it starts with the researcher, for instance, someone who's working in a lab with electronic lab notebooks. What we do here is we help you embed a small vocabulary lookup widgets, and those widgets are developed by the terminology-based services. It's another base services that we're working with from PID4NFDI. So they've developed the widgets. We help you integrate them directly in the fields where the researcher would fill in that information. So for example, in that concrete sense, in an ELN, a researcher needs to describe how that data set relates to a sample. And instead of writing like in free text saying, yeah, this is a data set, I got it from that sample, they can choose from a searchable list of control terms. They pick one, the closest one, and that's it. That's the entire user experience from that end. But behind the scenes, there is a lot more happening here. So something important just happened upon choosing that specific term. So when a repository or a tool has that, and I will get to that in the next step. But if you're working with an ELN, or any tool that would benefit from this, benefit from basically vocabulary integration, we would genuinely love to work with you and explore that. So we offer our consultancy services in terms of identifying the best points and what kind of structured metadata you can add. And we also facilitate the technical process of embedding those widgets, working with the terminology services. So here we've got the structured term. Next slide. Yes, that one. Yes. Here we've got the structured term bound to a specific that is gets stored. So the researcher chose a term. That term is stored in the records, and when the researchers made that selection, the system also stores a stable web address from the DataCite namespace, which you can think of it as a persistent identifier for that concept that the machine can read and translate. So this is not a schema. This is more. It does not replace DataCite schema for instance, but it's adding a semantic layer on top of that. So the namespace, what it does is that it gives every term in that DataCite schema and a permanent resolvable address on the web. And this is very important because that's essentially what the machines can go to and read and translate. So we have here the researcher chooses a term, the term is stored, this term is stored alongside with its machine readable and actionable information. So for this is also very important for people or communities working with physical samples, instruments, experimental data, anywhere where traceability and provenance is very, very important. So what we are offering here is we have created that namespace. We have it available online for machines to access it in a resolvable way, and we also maintain the upkeep. So when new releases are DataCite schema release is released and new terms are integrated, we create also those addresses for the new terms and so on. So that's the second service. And then, yes, the third component here. This is the third component where I'm sure a lot of you would recognize the struggle that comes here. Because what happens after that information leaves your tool? So when the record leaves the ELN, it might want to be integrated or exported into to a repository or into another tool. So to do this, the other tool, we cannot guarantee that it's using the same schema or can understand what we're sending. And if you maintain a repository where you do expose your data to either web searches or you share that metadata to other systems, you probably have had the pain of building your own mappings at some point. So whether this is a spreadsheet that you maintain or a script that translates the field, say from DataCite to schema.org or DCAT or another model, whichever model essentially that the next tool in line needs. So if you've been through that process, you know how fragile this is. You know when standards change, things break, and you need to redo it and maintain it. So what we're doing here is taking away that pain into a centralized space. We're working with the terminology services again, where they offer the Coda. It's a tool that hosts the mappings, and the mappings that live there. So, for example, we have the translation between is derived on in DataCite is based on in, I don't know, schema.org or Provo or something. So we have two schemas. We have mappings that tell this, tells machines that this term is equivalent to that one, and that lives in a centralized service or tool. And that tool provides a queryable API. So this is also to help make things more transparent, because it's not a black box with translations. It's the mappings are there, are versioned, they're updated. You can see when they were created, by whom, how often. So there's a whole lot of provenance around them, so you know you can trust them. And you can then use the queryable API, so the tool can, any tool, either upstream or downstream, can send an API question to that tool to say, give me the equivalent of that, so I can parse it in my tool. So every mapping is explicit also about its matches. You can see that this could be an exact match, this could be a close match. So you have a level of trust and confidence in the translation that is happening. So I'm not going to go too much into details, but if your service or tool need a mapping, or you've spent some time maintaining your own translations, please reach out to us. This is something we can work with you directly. This is as a service that we offer. We can also provide you with mappings or advise you on them, and we can support you in integrating those in Kokoda. And finally, what happens from there? From there, consumption happens, either downstream services. It can be knowledge graphs or repositories, or any place that needs to understand what has arrived to it. And that could lead to things like NFDI knowledge graphs or commons, or other NFDI tools can read that lineage. They can trace where that data set arrived from and how many translations have happened in between. And you can see every point in that workflow. And that, again, gives you trust in the data itself. And if you think about it, it's one step capture at the source that led to all of this work happening. And that's facilitated by PID's metadata. So that's it. That's all there is to it. Just choose the right term for it. Now, the next slide here, which is just to wrap it up and to provide you with the end-to-end example that we are working on. And again, it goes well to remind you that each of these components can be used on its own. I would love to hear from you how you could potentially use it, or how you can combine all three. So let's follow a single relationship is derived from. That's when a researcher chooses is derived from in the ELN. And in that case, that we're working on is with our space, and they choose it from a drop-down menu. That term is captured as a structured data, not free text, and that's where the journey begins. The term resolves to a persistent identifier from the DataCite namespace, from the permanent address. So any system downstream can look it up, can get the same definition. The meaning here is anchored. The semantics are anchored. And then that record can be exported to another schema.org based repository, for instance, and Kokoda maps that term is derived from to is based on. And that mapping, again, is explicit, it's versioned, it has a matching quality, nothing is lost in translation. After that, we can have the knowledge graph or the search portal or repository, whatever is downstream from there that receives that record with its full provenance intact. And that relationship that was recorded by the researcher arrives at the other end with the meaning preserved. So throughout this whole lineage, you have a capture, anchor, translate, and consume stages that represent our service components and represent the one unbroken chain of PID metadata carrying the meaning and semantic meaning across the NFDI. So this is what we envision, and that's what we're working on in the future. So a little bit of outlook in the ramp up phase. So next slide, yes. Yeah, so that's the broader ambition of our next phase in the ramp up, is to move from this foundational integration of that work towards something that can be fully operational, is something that is sustainable, you can rely on. It's not just a prototype, the prototype we're doing right now, we're working on right now, to show that this function is technically possible. And then what we want is to make that service as a reliable and scalable and maintainable thing that can be sustained beyond that project itself. So what we're doing is that we're working across 6 interconnected work packages. Next. Yes. And they fall a little bit, maybe broadly, into 2 groups. We have expertise-driven activities and we have infrastructure-driven activities, or more like what one is the human side of the ecosystem, like work package 1, 4, and 5. And these focus on policy, support, training, community engagement, and so on. They create like the governance and knowledge infrastructure that is needed for effective PID adoption and supporting the other PID-related activities that we can see in work package 2, 3, and 6. So, for instance, we have work package 1, which addresses a major gap in the current landscape where we don't have a PID policy across the NFDI. We have work package 4, which consolidates and professionalizes the work that we do, the services that we offer. We have work package 5 that ensures that the communities know about the work that we do and remain engaged and informed and able to discover and adopt these services. We have then the other work packages, like the more technical and operational infrastructure ones, like number 2, 3, and 6. 2 is the one that it sits in between. It really delivers metadata quality monitoring, interoperability services, semantic crosswalks, analytics. And I say it sits in between the human expertise and the machine actionable infrastructure, because we need the humans in the loop to make those decisions, and we need the communities to work with you to essentially create the crosswalks, understand your needs, how do we apply them. So all of that is all about operationalizing as much as possible the PID metadata that in some ways, like what we've just discussed in earlier slides. We have work package 3 that is focused on readiness and transforming the prototypes into stable operational services, and the work package 6 that addresses long-term sustainability, ensuring that that infrastructure is there for a long time and the governance models are in place, and things can continue beyond the project. So by the end of that, we have we aim to deliver across those 5 major pillars. We have first, like shared knowledge base, like we've already seen, PID coordination hub and cookbook and so on, and also machine actionable artifacts and crosswalks. So there's that. Second, there's the structured support services. So that consultations, training, help desk services, and community building. We have the metadata management services that includes metadata mapping support, quality analysis, reporting, interoperability, and so on. Fourth, we have the PID registration services and toolings, which Jana had introduced to us. So moving from prototyping into fully operational tools. And finally, we have the PID and metadata management tools. That's all. On how to look into compliance assessment or terminology lookups or instrument metadata exploration. So all of these components, we hope that they would position the PID4NFDI as something that in a long term could provide support and an infrastructure layer for whether PID governance or metadata interoperability or fair and operationalization across the NFDI. ecosystem. So yeah, with that, I want to say thank you so much. But I also want to highlight that we have an upcoming event. Next slide. Yeah, if you want to learn how to explore GUI metadata, we have an upcoming online workshop, which you do not need to know have any background information on how to use APIs or any technical background. What we're going to do is address all of that. We just need you to know about DataCite metadata schema. So if this is something that you're working with, and then I would definitely encourage you to sign up for that workshop. Yeah, so if you have any questions, any comments, happy to take them. And thank you all so much.
Yeah, thank you so much to our speakers for your presentation of PID4NFDI. I'd suggest we first say goodbye on YouTube, and I will quickly give notice that our next episode of the NFDI talk will be a talk about the Nomad ecosystem, which will be given by the technical coordinator at Fermat, Lori Himanen. And yeah, with that, I will stop the stream and we say goodbye on YouTube. Thanks again for the nice talk. Okay, great. We're back. And